All right, so we are on the second part of this example. And in the previous video, we found the following information, that there's no positive real zeros. And for negative real zeros, there's either 0, 2, or 4. Uh, so negative real zeros, either 0, 2, or 4, and no positive real zeros. So that was using Descartes' rule of signs. Now we're going to get into the rational zero theorem. And we may remember from our previous slide when we were looking at the rational, or actually no, it was 2 slides ago, when we were dealing with the rational zero theorem, we were interested in looking at the factors of P and Q. And remember, I'll quickly run through this. P is the factors of the constant term. And the constant term in this case is 16. Okay, and then we have Q, the factors of the leading coefficient. I'll abbreviate it like that. I want to go a little faster here. And the leading coefficient in this case, 3. Okay, so now we want to find the factors of 16 and 3. So let's look at 16. So again, we're about to find the values of P. So factoring P, we have 1, 2, not 3, but 4, not 5, not 6, not 7, but 8, 9, no, 10, 11, 12. Actually, there's no other ones until we get up to 16. And then we have 3. And this is the prime number, so we only have 1 and 3. All right, so we can now look at the table. We can build a table here, and we have P divided by Q, and we can just have the Q here for the rows, and then we could have 1, 2, 4, 8, and 16, and that represents our our P's. And we can build our table. Okay, so we have, now again, it's P divided by Q, so 1 divide 1, then 2 divide 1, 4 divide 1, 8 over 1, 16 over 1. And then we have 1 over 3, 2 over 3, 4 over 3, 8 over 3, and 16 over 3. All right, so if we wanted to find all the possible rational zeros, then we can take 1, so 1 divided by 1 is 1. So all the possible rational zeros is P divided by Q, again. So that would give us 1 from 1 over 1, and that's plus or minus. And then plus or minus 2 from 2 over 1, plus or minus 4 from 4 over 1, plus or minus 8, plus or minus 16, and then we have plus or minus 1/3, and then we have plus or minus 2/3, 4/3. Actually, all these are going to be unique. We'll see. Plus or minus 8/3, and plus or minus 16/3. Okay, but we're going to use the information we found from the last video to actually narrow down all the possible rational zeros. So if we just had the rational zero this video, then we would be done. But we can actually narrow it down even more because we know, and I'll use a different color here, we know that there are no positive rational zeros. We determined that in the previous video. No positive real zeros. So we can actually eliminate all the positives and determine that it's either -1, -2, -4, -8, -16, -1/3, -2/3, -4/3, -8/3, or -16/3. There's no possible way we're going to have a positive real zero based on what we determined before. So therefore, we can eliminate half of the possible rational zeros, and we just have the negative ones. All right, so we're going to be looking at these rational zeros in the next video. And we're done at this point. We just wanted to go over the rational zeros and combine what we learned from the Descartes' rule of signs. And this is what we get. And now we're going to be going into more depth in determining the result of this question, which is find the zeros of this function. So we're going to be actually referencing section 3.1, chapter 3, section 1, in the next video. So you may want to review up on that, and I'll go into more details of what you should be looking back from section 3.1. Okay, let me know if you have any concerns.